morning. Welcome to the Backyard Professor Math videos. I'm up here in the High C Resort area and it's a gorgeous morning. Sorry about the shaky camera showing you that wild turkey. He ran across the road. I darn near hit him, so I had to stop and video him. I think that's the first wild turkey I've ever seen here in Idaho. I know my old dentist used to go hunting them all the time, but today we want to learn about the positive and the negative numbers. With the negative numbers, well, and with positive numbers, we have a very powerful visual aid, the number line, to help us grasp how to deal with positives and negatives. I remember having a little bit of trouble with these myself when I first learned the concepts. You know, as kids, we think that 0 is the lowest possible number. And now that we've gotten more used to the real world, these negative numbers show up. And there's some tricks to adding, subtracting, multiplying, and dividing with the positives and the negatives. And I'm going to share those with you today. I want you to really enjoy putting up a number line for the next several sessions of these videos that I'm going to give you, because this will help us. When you can get a visual, math becomes much easier. And the other interesting thing about this number line is, you notice this arrow on the end points off toward the left, and this arrow on the right points off toward the right, going forever. We now begin to be introduced to the concept of infinity in mathematics. Even though we're not going to calculate much with infinity in algebra, all of mathematics is actually dealing with infinity, or parts of infinity. It's a fascinating topic. There's a lot of philosophy involved with it that I'll get to too. Later, other videos. Right now we want to learn the firm foundation of how to calculate with the mathematics so that we can begin doing some fantastic physics as well as mathematics. This introduces us to the idea of direction in math. Let me show you just a couple of quick basic rules with multiplication, division, addition, and subtraction with positive and negative numbers. First, we have the origin. Everything that goes to the right grows. Heavier in weight, bigger in size, longer in length, distance. Everything going to the left goes down. It gets smaller. So this introduces us to the idea of directions in numbers, right? Now let me show you how this applies. Let me show you how this applies to calculating in math. And when I saw this helped solve all the problems I had with positive and negative numbers, which is extremely nice. Very, very nice. We're going to start simple. 5 plus 2. This equation is telling us that on the number line, we're going to start here at 5. And because it's another positive number that we're adding to, we're going to bump 1, 2. We're going to go bump toward the right with this extra 2. I had a 5. Someone came along and added 2 to it. Now that becomes 7. All the positive numbers go toward the right. It's that simple. If you have 6 minus 3, what's that equal? This is telling us that 6, we begin with 6 in this particular equation, right there at 6, and we are subtracting. Adding increases, so adding takes us to the right. Subtracting decreases, so we go to the left. So 6 subtract 3 says we start here and we go 1, 2, 3. What number do we end up at? 3. So that's the answer. So you're beginning to see the idea of direction on the number line. If you can begin visualizing this, this is very, very helpful, because this one-dimensional number line, later on here in algebra, this will become a two-dimensional number line with the Cartesian coordinate system of an x-axis and a y-axis. And then we'll have two ways of calculating and plotting what our numbers are. And that is extremely helpful. That's one of the great inventions of math as far as that goes. That has completely transformed how we do math, that Cartesian coordinate system. This is the beginning of that. We have the idea now, because we understand the negative numbers as well as positive numbers. 2 minus 2, we start at 2, we're going to go down to 0. But now we also have this idea of 2 minus 3, right? You begin at 2 and you go 1, 2, 3, and you end up in the negative. Think of negative numbers as debt. If you make $10 an hour for 3 hours, $10 an hour for 3 hours, you make $30 an hour. If you owe $50, 50 minus 30, you are $20 in the hole. You are 20 below zero in debt. So negative numbers have a direct application in life. If you live here in the Rocky Mountains in the United States like I do, negative numbers mean a lot when it comes to temperature. When you get to 30 degrees below zero, brother, you're cold. That's how it works. Sister, you're cold. The idea of movement with positive this direction and negative with this direction can help us in our calculating. Here's the basic rule. Whenever you have a positive number, and what you're doing with a positive number is you are already beginning to the right side of 0. You begin with 1. 1 plus something. You're starting right here. This side of 0. You're already in positive territory. A positive number plus a positive number is always going to be a positive number. The reason why is very simple. Because you begin in positive territory to the right of 0, and you keep going that direction. There is no negative on this side of 0, on the right-hand side. It always goes positive in an orderly fashion all the way out to infinity. Now that's interesting because that tells us there is no such thing as the biggest number, doesn't it? You can always add 1 to the biggest number. You can always add 1,000,000 to the biggest number. You can always add 1,000,000,000 to the biggest number. It doesn't stop. You can always take away from the smallest number too. A positive number plus a positive number always equals positive. Conversely, the opposite effect of this is a negative number plus a negative number will always equal a negative number. Why is that? Because if you begin with a negative number, you're starting on the left side of 0, right? You truly are. So if you're starting on the left side of 0 and you add more negative to it, you go further left. So you always get a negative. Now, a positive plus a negative depends on which of those numbers is larger in value. Meaning to say, if you have a 1 plus negative 1, those are even values. If you begin at 1 and you have a negative 1, you add a negative 1, you go to the left, you end up at 0. 1 plus a negative is the exact same thing as subtraction. 1 minus 1. Because if you start here and you add a negative, you're adding to the left direction. Right? No, left. Let me show you this. Let me give you several examples of this that will help show us how this works. 5 plus 5 is positive 10 because you're adding more to the right. 5 minus 5 is 0 because you're beginning to the right of 0 and you're going to the left with that subtraction 5 units, which will end up at 0. With 5 plus 5, you go that away till you get to 10. 5 plus negative 5, you begin at 5 and you're going to add a negative 5. It goes that way to 0. So you can see that a subtraction and a plus negative, what we do with positive and negative numbers, which is really cool because it makes it easier, is we get rid of subtracting and we do nothing but addition. What we're adding is directions against each other. If we start with negative 5 and we subtract 5, we begin at negative 5. But subtraction is plus a negative. Plus a negative 5. So you begin with negative 5 and you add another negative 5. So you go further to the left. And that means this equals negative 10. Isn't that interesting? That's negative 10 too. A plus minus. We turn all subtractions into additions, but you have to change the sign. So you can see the effects. 5 plus 5, you start at 5 and go to 10. 5 minus 5, you start at 5 and end up at 0 because you go to the left. You start with a negative 5 and you subtract 5, then you go further left to negative 10. If you have a negative 5 and you add 5, then you are starting at negative 5, but you're adding positive 5, so you end up back here at 0. What we learn with this is really interesting. We realize that positives and negatives are reciprocals of each other. And what a reciprocal is it's just opposite. They are the opposites of each other. And you can see this very clearly on this number line. This is where this helps you. 1 plus negative 1. 1 plus negative 1. They're opposites. 2 and negative 2 are opposites. Yeah, that's a better way to put it. 1 and negative 1. I'm going to use parenthesis. Parenthesis really shows it powerfully there. We're not multiplying here. I'm just showing you the opposites. And then 3 has its counterpart with negative 3. 4 has its counterpart with negative 4, all the way out to infinity. 100 has its counterpart with negative 100. If you add those two together, you end up at 0. You go 100 paces to the left in the negative, then you do an about face, and you go another 100 paces to the right, and you're right back at your point of origin. Right? You see how that works? So these are opposites. They're reciprocals. They undo each other. Where have you heard that before? Adding and subtracting undo each other. Multiplying and dividing undo each other. It's the same thing. You notice this consistency in mathematics. This is one of the things I'm really beginning to appreciate in mathematics. The positives undo the negatives, and the negatives undo the positives. That is really cool to understand. Is it only this way with whole numbers, though? Absolutely not. It works with fractions, too. Watch this. 1/3 minus 1/2. Now we're in negative territory. We're going to subtract. First, what's the first thing with addition and subtraction? You know this by now. We have to have a common denominator, right? So this is going to be 2/6 subtract 3/6. And you can see 2 minus 3 equals negative 1. And then you bring your denominator over so that you're at negative 1/6. That's going to be right about here. You're left of 0, but you're not yet to negative 1. You're at negative 1/6. Now in fractions, you can have the negative sign on the 1. You can have the negative sign on the 6, or you can have the negative sign in front of the fraction. All of those fractions are negative 1/6. It doesn't matter where you place the negative sign. Those are negative 1/6 fractions. Just a small little deal to understand. So see, it even works with fractions. The positives and negatives work with fractions as well as whole numbers as well as the integers. The integers are just simply all of the natural numbers, that is, the numbers we count with, 1, 2, 3, 4, 5, 6, 7, all the way out. The whole numbers include all of the natural numbers plus 0, and the integers represent all of the negative and positives. A rational number is a number you can put in a ratio. That is a fraction, right? And it doesn't matter whether it's negative or positive because the rationals include all of them. 1/2 is a rational number. 3/4 is a rational number. 7/8 is a rational number. You're just putting 7 and 8 and 3 and 4 and 1 and 2 in a relationship with each other as numerator and denominator, right? And I'll get to irrationals later. Irrationals just have a decimal point that never has a pattern or repeats, like pi, the square root of 2, the square root of negative 1, things like that. Well, the square root of negative 1 isn't irrational, it's imaginary. I'll get to that later. When we multiply positive and negative, when you multiply a positive by a positive, you always get a positive. When you multiply a negative, multiply by a negative, it always is positive. And when you multiply a negative by a positive, it always equals a negative. Now this is interesting. If the signs are the same, the answer is the same as the signs of the factors. If whether they're both positive, it becomes positive. However, with this part, it gets different. With 2 negatives, it becomes a positive. And with only 1 negative and 1 positive, it becomes negative. Let me show you some actual numbers in the multiplication that will show you this. Well, first, I'm jumping ahead of myself. Let me do a little bit of addition and subtraction for you. There's one other trick that I want to show you with adding and subtracting negative numbers. I'm getting so excited about this, I'm already jumping ahead of myself. Boy, now there's a lousy teaching method, right? 3 minus 6. This is the same thing as 3 plus negative 6. We turn the subtraction into an addition. We start at 3. We're going to go 6 places that way. 1, 2, 3, 4, 5, 6. We're going to end out at negative 3. Now look at this. Take away the signs. Just look at the numbers. 3 and 6. Which one of those numbers is bigger? 6, of course, because it's over here to the right, right? How much bigger is it than that 3? 3, right? Therefore, you know the answer is going to be 3. But you look at which number has the negative sign. The bigger of the numbers that has the negative sign means it's going to be negative. So that was going to be negative 3. If it was negative 3 plus 6, we would be starting at negative 3 and going over 6. It would be, I'll do it here. It would be positive 3, not negative 3. Do you see why that is? Because now the bigger number is positive, therefore the answer is going to be positive. If the bigger number is negative, then the answer is going to be negative. And this works with all the numbers. Let me show you again with another example and with this wonderful number line to help us see the direction we're moving. What if we had 4 minus 9 equals what? We turn the subtraction into an addition. 4 plus a negative 9. So, which is the bigger number without any of the signs? 9. What sign does the 9 have? A negative. So you know your answer is going to be negative. There is no question about it. What is the answer? What is the difference between 9 and 4? The difference is 5. But it's going to be a negative because the larger number has the negative sign. The number line helps us see why. This is the beauty and power of this number line. This problem says we begin with 4. We start here, 4. Subtracting 9 goes that way to the left. We are taking away, so it's going smaller. Adding the negative means the same thing. We're going to add a negative 9 points to this. We go over 9 and we go 1, 2, 3, 4, 5, 6, 7, 8, 9. Look where we end up at. Negative 5. Just exactly like I told you. The difference between 9 and 4 is going to be 5. 9 has the bigger value and it has the negative, so we know the answer is going to be negative. When we see the proof of this with the number line, it makes perfect sense. Remember, math is an argument. This is the beauty of math. Math is an argument, and you want to prove your case. You want to make a statement, and you want to show your work. If you're in school watching these videos, I absolutely promise you, show your work, you will get credit for it. Even if you give the wrong answer, you will get partial credit. You want to show your thinking. You want to show the logical reason why you're proving 4 minus 9 is the same thing as 4 plus negative 9, and it equals a negative 5. If you was to draw a number line and say, see, this says I'm starting here at 4, I go over 9 units, and I end up at negative 5. Not only do I prove this mathematically through the calculating, I can demonstrate this visually with the perfectly consistent logic of the number line. Now, back in ancient Babylonian times, back in ancient Egyptian times, etc., 6 was always larger than 3. Always. 6 is always larger than 3. You can see that. That's because 6 is always to the right of 3. That was true in ancient times. It was true in the times of the Romans. It was true in the time of Jesus. It's true in Benjamin Franklin and George Washington's time. It's true today, and it's going to be true in 1,000 million years from now. This is the power of the consistency of mathematics. Knowing this information, that these numbers will always be in this alignment, we have a powerful tool here for a visual proof demonstrating the accuracy of our claims of any equation. Ha ha ha, that rocks, baby. You want to show your work so that you can prove it. Anyway, one more. I think I've got time for one more. I'm trying hard not to draw on this number line because it erases so easy. Let's say we want to show the statement of, let's see, I could only draw 7. Let's say 7 minus 12. And you go, 7 minus 12, that's right. We can subtract a larger number from the original now, thanks to the integers on the number line. This is the same. We turn all subtraction into addition, but as we change this sign, we change the sign of the next number we're working on. So 7 minus 12 is the same thing as 7 plus negative 12. This statement, we argue, says we begin at 7. I mean, how can you refute that, right? You begin at 7 and you go 12 over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Bingo. I argue that this is a negative 5. Another way I can show this besides the absolutely perfect logical number line is you draw the numbers 7 and 12. Which number is larger? The 12. Why? Because it's always going to be to the right of 7. And anything to the right grows bigger. That's one of our arguments. What is the difference in value between these two? 5. 12 minus 7 equals 5. In this equation, the negative 12, the 12 has the negative, therefore we argue the answer will be negative, and when we visually show it, we end up in the negative territory, don't we? So we are justified in saying this answer is negative 5, and we have proven the point. That is so cool. I love that part of mathematics. So anyway, I'm out of time. I'm trying to look at my clock. I have half-hour length videos that I'm allowed, which is nice. At least that's the only thing I'm going to be able to upload for now. Maybe it's my computer or my server or something. But so this is the idea, and what I want to do is I want to show you more on multiplication and dividing of negatives and positives in the next video. So thanks for watching my videos. I hope you enjoy them. I love coming out here in the beautiful scenery and doing my videos. Let me show you this real quick where I'm at. It's really gorgeous. The sun's just coming up. I got up at 5 o'clock this morning to get out here. There's our beautiful forests. So thanks for watching my videos, man. Happy calculating. Have fun calculating. Have a great life. And I'll see you guys in the next video.